Okay, today's lesson is on integrals. So we're integrating. Now, integrals of exponents. Well, before we take an integral, an antiderivative of an exponent, let's take a derivative of an exponent and remind ourselves what's going on here. Right? If you can't drive forward, you sure can't drive backwards. So let's remind ourselves how we drive forward first, and then we'll see if we can drive backwards on exponents. So taking a derivative. So this is just thinking forward. I don't have to go backwards on anything. Do you remember what the derivative of e to the x squared is?
2 e to the x squared.
You're getting close.
E to the x squared to the 2.
Okay, so it involves e to the x squared. That is true.
Then you take the x squared.
Times the derivative of x squared, 2x, that's the chain rule. Okay, so maybe let's do one more of those because that was a little rough. Let's do e to the tangent of x. Take the derivative of e to the tangent of x. Tyler, what's the answer then?
E to the tan x times secant squared.
Yes, e to the tan x times secant squared of x. I heard you say it's just secant squared, and that made me nervous that your whole answer was just secant squared.
Yeah, you didn't
But
hear
if
the tangent.
I didn't hear the full thing, and of course you were correct. So e to something is e to something, but chain rule. So chain rule, chain rule, chain rule. And so today we're going to be worried about undoing the chain rule. The antiderivative of e to the u du, going backwards. Do you know what that would be? Just e to the u. Well, plus c. Don't forget the plus c. All right, let's do some examples. E to the 5x dx. This is one of those that after we do a bunch of these, you might be able to do without showing the u substitution, but I'm going to show it to start with because I want it to look like e to the u du. So in some ways, picking the u for these is easy because u almost has to be the exponent. It's the only way this is going to work. It's the only way it's going to look like this, for sure. So I'm going to let u be the exponent, and then basically hope that everything works from there. Yeah, I think e is going to always be, u is always going to be the exponent, and then you basically just hope that it works. And for us, it will. So they're sort of rigged problems that will work out for us. So du is 5 dx. So what do I need to do to sort of fix my integral? Yeah, put a 5 in there and a 1/5 out front. So now I've got 1/5 integral of e to the u du. And the integral of e to the u du is just e to the u. So 1/5 e to the u plus c, which is 1/5 e to the 5x plus c. And rarely do we take the time to check these, but if we took the time to check it, I mean, this one would be easy. The derivative would be e to the 5x times 5, and then the 5 and the 1/5 would cancel out. Well, that's about as easy as they get. Let's make them a little bit harder here. Let's do the integral of 4e to the 1 minus x dx. What do we think u should be? 1 minus x. I mean, I don't know when it would not be the exponent. I mean, I'm sure there's some situation somewhere where that wouldn't work, but for us, if there's an e to a power, u is almost always going to be the power. So du is negative 1 dx. So how do you want to handle this one? I mean, what do we do with the 4, I guess, is the main problem I'm looking at. The negative's easy. I can put a negative 1 in there and a negative 1 out front. Yeah, just take the 4 out. It's kind of in the way. So I'm just going to move the 4 out front. So now I have negative 4 out front. Integral, or antiderivative, of e to the u du. It's like, well, in some ways, all these problems are the same. They're all antiderivative of e to the u du, which is just e to the u. Negative 4, e to the 1 minus x. Oh, I plugged it in on the fly. I didn't even need to write that again. So it's all about getting the u and du and fixing the integral so that it works. Once it's fixed, they're kind of all the same after that. So let's do one more that's relatively straightforward, and then we'll start throwing curveballs in the mix. So you try that one. Antiderivative of e to the sine x cosine x dx. Straightforward. Okay, well, let's see what happens if we mix this up a little bit here. E to the 4x plus e to the, plus 2 e to the 2x plus 1 all over e to the x dx. What do we think? Algebra. Let's do algebra first. Otherwise, I don't know what u would be that would make any of that work. So let's do some algebra first. So what's e to the 4x divided by e to the x? Good, e to the 3x plus 2 e to the x plus, how do you want to write the that last term? E to the negative x. Now we could go and do u substitution on each of those individually, but my guess is you could probably do it without writing everything out. What's the antiderivative of e to the 3x going to be? I mean, you know it's going to be e to the 3x, but what would I need to sort of fix it? A 1/3. Antiderivative of e to the x is just e to the x, so that one, there is no fixing. Or maybe a better way to say that is the chain rule of x would give you 1, so I don't have to worry about anything extra. E to the negative x, so I know it's e to the negative x. What's the chain rule of negative x? Negative 1, so I need a negative on there to kind of fix that. And then plus e. So So that one wasn't too bad. It just had an algebra step at the front end of it. Antiderivative, e to the 1 over x over 2x squared dx. E to the 1 over x over 2x squared dx. Thoughts on u substitution? What's that? One more time, I just didn't hear you. What do we say our usual rule is? It's always going to be the exponent. If there's, I mean, that last one had some algebra up front, but I can't do anything algebra-wise. So let's let u be 1 over x, which I might need to rewrite as x to the negative 1 so that I don't mess this up. So that derivative would be negative x to the negative 2, which again is, I don't like negative exponents, except that they're much easier to take derivatives of. So that would be negative 1 over x squared. I would classify that as good news, right? Because we've got an x squared in the denominator. So I'm close. What do I need to do to fix this thing? Okay. So there's a couple ways to say that. That's an okay way to say it, is to multiply by 2 to make the 2's go away, but then put a 1/2 out front. The other thing you could do is just slide the 2 out front, and then you'd have a 2 out front as well. So either way. And then I need a negative on that, so negative and negative. So negative 1/2 is out front. Let's see. All of that is du. 1 over x is u. So this turns into every other problem on this unit. The antiderivative of e to the u du is e to the u. So e to the 1 over x plus c. With that negative 1/2 out there. Antiderivative of natural log of e to the 2x minus 1. Maybe looks bad, but algebra, remember a property of natural logs we can use? Natural log of e is 1, that's true, and that will help. But before I could take the natural log of e, I'm not taking the natural log of e, I'm taking the natural log of e to the 2x minus 1. So yes, the natural log of e is 1, but I can't use that, at least right now, because that e has an exponent on it.
Does natural log and e cancel out?
They do. So what does that leave me with? Or do you know?
Wouldn't it just leave you with 2x minus 1?
It does. Another way to say that, or how some people remember it, is that the exponent can come down front. So I have 2x minus 1 out front. And then, yes, natural log of e is 1. So you guys are kind of saying the same thing, Gabe, that you cancel each other out and you're left with 2x minus 1. Out front, though, not as an exponent. So this isn't even a natural log or e problem anymore, because e and natural log cancel each other out. This is now just antiderivative of 2x would be x squared over 2. Well, the 2's would cancel, but minus x plus c. And just to continually emphasize the safe stop fun, we'll just leave the 2 over 2 sitting there. I don't know. It's just kind of weird to think about. In Algebra 1, you'd lose a point on your answer if you left that, right? You can't leave that. But we're beyond that. We're not worried about that kind of stuff anymore. Let's do one with, I need to do 2 more. One with limits and one with a differential equation. Antiderivative or integral from 0 to square root of 2 of x e to the negative x squared over 2 dx. So limits, so I know I got to plug in limits at the end somewhere, top one minus bottom one. But that's it, that's later. Let's do the u stuff first. Again, almost always u is going to be the exponent. So negative 2x over 2 would be negative x, which is good news. Not quite perfect news, right? Because I need to fix the negative thing, but that's an easy fix. So negative integral. I'm not going to write the limits because I'm in the process of switching from x stuff to u stuff. So there's du. Speaking of switching, I may as well switch them. So the top limit, see if I plug in square root of 2, I get negative 1. So my u top limit is negative 1. And my u bottom limit, that's an easy one, is still 0. And again, the negative, do you want to switch those or use the negative to switch them or just leave it and don't worry about it? I think I'm going to leave it and don't worry about it right now. So negative e to the u, because antiderivative of e to the u is e to u. From 0 to negative 1. So negative out front, e to the top one, minus e to the bottom one. And that would be a perfectly acceptable free response answer right there. I mean, there's a lot of messy stuff going on, but it would be an okay free response answer. The reason I did this one is because on a multiple choice test, if that shows up, you know that's not going to be the answer. It's going to be, let's see, e to the negative 1 is 1 over e. E to the 0 is 1. So that's a little bit more cleaned up. Calc Chat likes to get a common denominator, you know, because why not? So negative 1 minus e over e. And then probably one more step after that, if you distributed the minus sign, you'd have e minus 1 over e. So the real purpose of working that problem was the algebra stuff at the end to remind you that, you know, if you get here and you don't see that as an answer and you see this as an answer, you know, can you get from here to here? I hope so. You know, you don't want to miss a calculus problem because your algebra let you down. But it happens sometimes. So again, just be alert, make sure you know your algebra rules. All right, last one. Find the particular solution. So that means figure out what C is. Like plus C is the general answer. If you can figure out C, then you've got a particular solution. If f double prime equals sine of x plus e to the 2x, f of 0 equals 1/4, and f prime of 0 equals 1/2. We've done a couple of these type problems before on tests, on previous homeworks, warm-ups, that sort of stuff. So this is, it's not new, it's just new with the e to the x stuff. So let's take an antiderivative. So we'll go from f double prime to f prime. All right, that was an antiderivative. So what's the antiderivative of sine of x? Good, negative cosine. The antiderivative of e to the 2x? It's definitely going to be e to the 2x, but then what else is going to be there? A 1/2. Not a 2, right? Because we're antiderivatizing. We're going backwards, so we need a 1/2 to counter that 2 if we were taking a derivative. And then plus c. And so we'll use that first, well, we'll use the first derivative solution to figure out what c is. So the answer is 1/2 negative cosine of 0 plus 1/2 e to the 0 plus c. Man, look at all the stuff you got to know in this one. The cosine of 0 is not 0, 1. E to the 0 is 1. So let's see, 1/2 equals negative 1/2 plus c. So that means c is equal to 1. So f prime. This step in here is where I sometimes lose people, because they'll find that and then they won't include it before they take a second antiderivative, or they back up one more step. So c is 1. I need to include that in there. So now when I take another antiderivative, I will have accounted for that. So let's back up one more step. Oops, not 0 yet. Do that in a minute. So I need the antiderivative of negative cosine. Uh-oh, what's up?
Isn't the derivative of sine of x positive cosine?
Yes, the derivative of sine is positive cosine,
Oh, but okay.
but we're going backwards.
Okay, sorry.
That's okay. We're going backwards. Speaking of going backwards, we're going to go backwards again. What's the underderivative? I'm going backwards of negative cosine. Negative sine. And I know e to the 2x will still be e to the 2x, but I need to go backwards. I need to sort of unchain rule this thing. So what's going to be out front? Let's see. I want it so that if I multiply it by 2, I get to 1/2, so 1/4. Divide by 2 again. Plus x, so that's where if you left off the 1, you would leave off the x somewhere. And then plus c, although this is a different c, so you can still say plus c because you've kind of already substituted an hour to a separate part of the problem. If you want to say c2, because that helps you, sort of distinguish between the two, that's okay as well. Now I want to use this piece of information. F of 0 is 1/4. Sine of 0 is 0. E to the 0 is 1. So C2 is 0. So my final answer, trig, exponents, derivatives, antiderivatives, algebra, plugging stuff in, 2 different C's. A whole lot going on in that problem. All right, the assignment, page 354, 91 to 117, 123 and 125, and odd applies to all of that. A whole bunch of e to the x, e to the u, du. It's just about picking u correctly. But then there's some algebra stuff thrown in and some find the solution stuff like that last one we did.